I'm going to try to do a short talk, then just show the live demo of LlamaZOO's projects, so we can have an actual idea of what is I'm talking about. So first of all, let's see if I can get an awesome logo playing. Didn't play. No mind. LlamaZOO is a software company, and we are based in Victoria. We currently have about 23, 25 people, and we focus on the topic we call that 3D and geospatial business intelligence. And we do these visualization projects for all these cross platforms, from the traditional desktop monitors to VR headset to HoloLens goggles, and we also support like mobile devices. Like the same content can be imported for all these cross-platform devices. Now what I'm talking about here, like 3D and geospatial business intelligence, that's a pretty blurred business buzzword. In the next few slides, what I'm going to do is I'm going to try to actually define the core problem that LlamaZOO is trying to solve with our visualization platform. I'm going to use an example of mining, since we work with the resource sector a lot. And I'm going to try to narrow down that core problem that our enterprise clients have here. Mining is about taking materials out of the earth and process that for the industry. But the mining projects are usually much more complicated than dig a hole in the earth and then you take a piece of rock out. I have this really neat illustration from the International Institute for Environmental and Development, which shows that to initialize and carry out the actual mining projects, you have so many complicated aspects that you have to coordinate together and to make the final thing work. For example, you have to start with the policy and regulatory relationship. You have to talk to the government to claim a piece of land, usually a very large landscape for you to dig up. And then you have to secure the capital and investors part. And then you do your technical study of geology and hydrology to plan your mining. And then you execute that technical plan, but taking into consideration of environmental control and community engagement, so the people living around your mines not getting pissed off by you digging a lot of dirt out of the ground. Luckily, we live in a modern era, and all these individual problems are readily being solved by some really advanced technical solutions. For example, for geology planning, we have MapTech. I think that sorry, I forgot your name. But when we talking about geology, you must know about MapTech, right? Like that's a very common planning platform, and we have similar technical solutions for hydrology and environment, wildlife, and we have professional teams in every mining company to take care of government relationship and community engagements. Every field has their own experts, but they don't talk to each other. All these disciplines are highly specialized, and it is very difficult for a larger mining company to aggregate and correlate all these different domain expertise into a coherent, high-level mining plan. And that is the core problem that LlamaZOO is trying to solve with our visualization solutions. In the business world, we always use a word called silos, and we say that all these geology and hydrology and environmental expertise are silos of data and knowledge, and they are isolated with each other, and we are trying to break all those silos. So what does silo actually mean? Well, I just found a picture of silos on the Granville Island, and I think this artist got some really precise idea about the meaning of silo we use in the business world. So as you can see, all these guys, they stand very close to each other, but they don't talk, and they are facing different directions. And that is exactly the situation in our mining company clients. Like they got all these tons of talented people. Everyone come from a different discipline or different background, and they sit in the same building, sit in a different department. They try to talk to each other, but they can't because every discipline has their own language. Every discipline has their own very specific domain knowledge. And how do we as a third-party visualization service provider to break that barrier between these silos and take these silos down and let all these experts to talk to each other and form that coherent idea of resource sector development? Well, the core methodology we use here is what we call digital twin visualization. So before defining what that is, because I think all the word digital twin has been used a lot in the business world. I think as the venture capital investors, you guys are much very familiar with that. But we have a very specific definition of what kind of digital twin we do. So our methodology is based on two important historical branches of computer-based rendering or computer-based image synthesis. The first big branch is called scientific data visualization, in which you try to express extremely complicated specific domain data, but you have a toolbox which we call gestures. Gestures means these abstract kind of lines and clean-cut drawings and all these pseudo-color codes that allows you to express huge amount of information concisely in a limited visuality. Every discipline, for example, geology, hydrology, and environmental control, they will have their own scientific data visualization scheme. They know how to draw their own data, but one guy from one discipline won't be able to understand the data visualization or scientific data visualization from the other department. The other branch, maybe a bigger branch of computer-based rendering is what we call photorealistic rendering, which is extensively being used in video game and feature films industry. On this branch, you're not too concerned about the precision of the data, but you want the visuality you generated to look as real as possible, to be indistinguishable from what you get from a real camera taking a photo towards a real scene. The concept of digital twin visualization in LlamaZOO is that we're trying to combine the strengths of the two. What we're going to do is to establish a common, a unified common picture of the background where all these domain-specific data reside in. And then we try to make intuitive visualizations, but they're not in an abstract environment. They are being overlaid on top of this photorealistic rendering of that actual mine project. The end goal is to let people from different disciplines, including all these layman people, for example, the regulators in the government or the stakeholders of the mine, to easily kind of communicate with each other about any kind of specific domain knowledge they want. So I have another example picture here. Basically, what you can see here is a really vast landscape, and then a realistically rendered mining pit. But then the ore body in there is being constructed according to the real 3D data coming from the mine. That is geologically accurate. But we also have these easy to read labels that's being linked to these geological bodies. that just enables a much smoother communication between different parties, between different disciplines. They come together and we can easily get a good understanding of what is going on. LlamaZOO's core technology includes everything from a regular desktop display. For example, you may run Unity just on a laptop, which is what I'm going to do a bit later today. And we support all these fancy latest VR and AR headsets. But the point here, again, is that LlamaZOO's visualization platform is endpoint agnostic. That means the content is going to be built once, and then we can just render that the same content in different platforms by just basically porting the same code and digital assets using Unity and Unreal pipelines. So without too much talking, let me just try to show a video demo first. Show that. All these videos don't work. Just play it here. So this is a different product that I didn't bring a live demo today, but I got this video. It's called OCC 3D, or Operational Command and Control 3D. This is designed for the easy communication between the whole truck driver of a mine and an on-site supervisor and an off-site manager and a mine planner, for all of them to get a very easy understanding of what is going on in real time in an operating mine. So as you can see, the entire mining, the entire mine the project site is being reconstructed in 3D using photogrammetry, and it's physically accurate. It's being updated once a new photogrammetry comes in from the surveying drones on the mine. And the status of every running haul truck has their label on these trucks. And including the engine status and other relevant operational data. So this app is for an operating mine, for the supervisors to get a higher level understanding of what's going on when the mine is running. The next demo I'm going to show. The next demo I'm going to show is about mining planning. It deals more about the geology planning parts, and it tries to optimize the process of getting, for example, government approvals and community engagement to show what's really going on a past and a future mine. See if I can fire it up here. I see the two small llama running on the screen. It's really doing some hard work. So this app is cross-platform, and you can run that in a pair of wipe if you have that. You can run that in HoloLens. And it's the same content, but the content is being scaled. For example, if we build a HoloLens app, we don't want ultra high definition of the art asset, otherwise the HoloLens won't take it. I probably have to turn my film around. So that's the 3D model of a mine that contains all the data layers from 20 years ago and until 20 years in the future. So the future data is from the planning of the mind, and it's from their blueprints and drawings. As you can imagine, it's pretty hard to read a stack of like mind planning documents and try to understand what will really be dig out on that mountain. But with our app, for example, if we enable all the geology layers, that is the geology, and then we can kind of put up all the drill holes throughout all these years, and then we can get a really direct and intuitive understanding of how the digging was happening in the past few decades, and how it's going to happen in the next few decades. This entire landscape of about 400 square kilometers is being reconstructed, or sometimes we say that's being trained in the digital world in a platform agnostic way. So you can view this thing on a smartphone or in a web or on a desktop. Now let's focus on that geology, that geology and drilling hole a little bit. So here I want to show what do I mean by saying it's a digital twin visualization. Now, all these drill holes are just being drawn like a cylinder, and there are so many of them. And all these yellow sticks going into geology looks pretty similar to a traditional scientific visualization. Like, that's what you expect when you fire up a geology app and try to read in the data sets of drill holes. A lot of apps can do that. But LlamaZOO's specialty in here is that if you just lift your gaze up, you can see the entire realistic environment where all those complicated data resides. And you can get a really good sense of where are actually those drill holes. Well, we are here, and we have this intuitive spatial relation, for example, to that part of the mind. And in this app, we can, of course, play around like a video game. Everything you expect from a first-person shooting game will be in here. I mean, it's Unity, so we have this strength of producing really high-quality interactive experiences, and that's a facility, telling facility. And if we try to go up the really, yeah. So if we teleport ourselves a little bit, we can look at the entire 400 kilometer square landscape from a really high perspective, and you get an even better understanding of where all these things goes. And if you want to see that plan, just teleport to there, and you say, oh, here's two, for example, two roads in here, and that's the territory that's being claimed by the mind. They're going to dig everything out from here, and that's immediately evident that those, I'm not sure if that's a real viewer, but those original landscape here will be destroyed, and then it just makes things so easy for our clients to talk to like the communities or the government regulators, try to go through their mining plan and to communicate and improve the mining plan and try to maybe get approvals. I want to say this app, in its first 3 months of deployment, has saved our clients about $200,000 in saving site visit trips, because what mining company used to do is they will fly, like physically fly a government officer around a real mine, and there are a huge amount of security and personal scheduling considerations going in there. Now, if we run this app in VR, any regulators can just put on a pair of VR glasses and just fly around the mine in the office. That's a great ROI we got like, in the first few months of deployment. I think I'm going to stop talking by myself here and see if anyone has any questions.